This is our 12.1 day 1 notes where we're going to focus on finding the limit through looking at the table in your calculator. So my first recommendation is to change some of our table settings. So go to second window, and where it says change in table, I want you to change it to 0.01. It's going to just allow us to see what's going on a little more closely. And then for your table start, change this value depending on the x value that the limit is approaching. So for example number 1, with the finding limits with tables, the function is 2x minus 5 as x approaches 3. So I am going to make sure that my table starts at 3. And then in my y equals, I'm going to have my first function, just ignore the stuff underneath. My first one is 2x minus 5. So now I'm going to go look at the table, and I'm going to scroll up just a little bit because I want to see what's happening from the right and left side as x approaches 3. So as far as the notes go, the little table that you have would allow you to fill in this part. So you have your limit of 3 right in the middle, and then a couple above, couple below. So as we approach 3 from the right side, that's when your x values are a little bit bigger, but you're approaching from the right. And then here's where we're approaching from the left side. So this one's a pretty clear example that we are approaching 1 from the right and we're approaching 1 from the left. And if I asked you to evaluate f of 3, the evaluation would be that y equals 1. So for your notes, the limit does equal 1 for number 1. Okay, now I'm going to look at example number 2. So you want to type that function into your calculator. And now I'm going to change my table start to, I'm not going to change it at all because it's still at 3. We're still approaching 3. And here's what our table looks like for number 2. So again, for your notes, you'd be filling in this part right here. You want your limit right in the center. Now, as we approach from the right and the left, you can hopefully tell that we are approaching 7 from either side. And as long as we're approaching 7 from the right and the left side, the limit as x approaches 3 will be 7. Now, if I asked you for the evaluation, notice you have an error. So the evaluation would be undefined, but the limit still exists because it is approaching 7 from either sides. So it doesn't matter what happens at exactly x is 3. It's just what's happening from either side as we approach x is 3. All right, next we're going to look at number 3. So you want to type that function into your calculator. And now the limit is x approaching 1. So I am going to change my table start to 1. And then I'm going to go to the table, scroll up a little bit. And then for the purpose of your notes, you would be looking at these values right here. I had to fix that a little bit. The other problem was still showing up. So here's our example number 3. Here's the table that we're looking at. So as we approach from the right side and as we approach from the left side, the limit as we approach x is 1 from the right appears to be 1. And the limit as x approaches 1 from the left appears to be -1. Since these do not match, the limit does not exist. So the limit as x approaches 1 does not exist. If I asked you to evaluate at 1, it would also not exist. It would be undefined. All right, the next example, I'm actually going to skip to number 5. So you want to type that one into your calculator and change your table set to start at 1. All right, here is your table for example 5. This one can be a little tricky to notice. As you're approaching from the right, what you want to be aware of is how quickly these numbers are growing. This is an indication that we are going towards infinity, and you can always take a look at the graph to be sure. So because the numbers are jumping pretty drastically, the limit as we approach 1 from the right is infinity. And as we approach from the left, again, you're noticing just the increase in these numbers, and you can always look at the graph if you need to. But this is approaching negative infinity. And since these two do not match, the limit as x approaches 1 does not exist. All right, and the last example is going to be number 6, and you're going to want to change your table to start at 5. All right, so I have my table set to start at 5, and then I'm going to go look at the table and scroll up a little bit. And as we approach from the right, our numbers are a little funky here, but it does look like we are getting closer and closer to 0. And then as we approach from the left, all those error messages is your indication that the limit does not exist. And since the right and left side does not match, our limit as x approaches 5 does not exist.